Hey everyone, I have David Julia here today, who is head of engineering at Eagle.io.
Hey
David,
everyone.
thank you very much for taking time to speak with me today. Would you like to introduce yourself?
Yeah, absolutely. So David Julia, head of engineering at Eagleio. So we do environmental IoT. So we're an environmental IoT data platform essentially. You connect up all sorts of devices to us. We're used in water monitoring, natural resource monitoring, various other things. Even they use us to monitor the cracks in Mount Rushmore, for example.
Wow.
How Mount Rushmore is splitting and how that's going and whether they need to remediate anything. So, a broad variety of use cases, all these data loggers, sensors connected to the platform, and analytics and processing logic on that. Fun gig for me. I just started that a couple of months ago. Before that, I was in software engineering consulting for a long time, about 8-9 years at Pivotal Labs and then VMware. Fun little project that we're working on now, and had the chance to jump into some cost attribution stuff as part of it, hence the conversation today.
Very cool, yeah. Thanks for reaching out on Twitter. So maybe which cloud providers are you using, or could you share it with us? So all this IoT stuff is
Sure.
feeding data directly to the cloud, or is it going through a bunch of gateways in between?
Yeah, so maybe I'll give the 30-second version of how it works. We're a multi-tenant SaaS platform. So the whole value proposition of Eagleio is unlike AWS IoT Core or Azure IoT, we think of those as primitive building blocks, which, if you want to build your own solution, cool, go nuts with them. But we're, much higher up the stack than that. So, essentially for these engineering firms or big, municipal water companies, state water companies, mining companies, that they don't really want to build a bunch of, mess around with all of this code and IoT core and all of this different stuff that's out there, which is really cool, admittedly, but not core to their business. So they just hook up to us, and very quickly they're able to get data in, analyze it, alert on it. Like if you're monitoring a dam, for example, you want to know if a dam wall is failing. You don't really care about configuring microservices or anything like that. So we're a multi-tenant SaaS application, lots and lots of different users, but a lot of shared resources as well. And so that's kind of the layout.
Perfect. And maybe you can tell us then why in this context, or what do you mean by cost attribution, and why do the whole cloud costs matter as part of that?
Yeah, sure. And I just realized I didn't answer your previous question initially. We're mostly AWS, right?
Cool.
And so why cost attribution? Well, it's pretty fundamental, especially when you're building a data intensive application like ours. But also in other circumstances, you really just want to know, one, can I guarantee that I'm going to make good gross margin? And two, if I add more customers, am I going to be adding more profit or not? Is it going to be impacting my gross margin positively or negatively? And if that's a very big question mark, that's something to be nervous about. And that's actually the situation we found ourselves in. We were negotiating with a particular enterprise customer who wanted to essentially more than 10x their usage of the platform. And so they said, well, and they said, hey, you got to give us a discount for this to be financially feasible for us to do this. And we want to do this deal. You guys want to do this deal, but we need to make it in the realm of dollars and that we can actually do. And we said, well, we should be able to do this, but our current pricing model doesn't scale for them. Or maybe it's just the numbers, but if we give them too deep of a discount, are we going to lose money on the thing? like we don't know, like what are our costs? What's their usage? What's even driving our costs? So that's when we really sat down and said, okay, we need to figure this out. And the guys had suspected before I got there that the current pricing model, which is you pay for essentially you pay per data source. So a data source is like a device that's connected to the platform, spitting out time series data to us. So it could be like a little water monitor that's measuring flow rate and temperature and battery voltage. And we had some levels of tiering in our pricing model in terms of like basic accounts, pro accounts, and there was some tiering based on pricing. So like, or based on the size of the source, meaning the number of parameters you could actually send us. So we do some tiering based on small, medium, large data sources, and those have different price points depending on the tier of account that you are with us.
Okay.
So if you're like in a pro account, you pay a little less.
Okay, I see. But it wasn't like detailed down to like, this much data is being produced, so then we're kind of like have to mark it up by this much or do anything like that.
No, so I think, I don't know if that would necessarily make sense. We did talk about that as a pricing model, that like really true usage-based pricing.
Okay.
But no, our customers aren't really like software people. They're not really, some of them are, but only as a means to an end.
Yeah.
So they don't like thinking in gigabytes of data or
complicated.
They just want to know like, I hook it up and how many things am I sending it to you and how frequently am I sending it? And they don't want to deal with the calculation of, oh, well, if I'm sending an integer, it's this. If I'm sending a string, it's that. And they don't want to care about any of that. So we had a very simple pricing model there. But with that simplicity actually drives a much more complex model around, well, how much is it going to cost us
to
service you as a customer?
Okay. And the kind of conversations I've seen in this space are normally with companies like, I don't know, Segment, or much like large companies who are either getting close to IPO or like looking at like cost of goods sold and things like that. Why does this stuff matter for like earlier stage companies then?
Yeah, well, I think there are two things. One is, if you're just trying to prove product market fit and you're like super early, it might not really matter, especially if you've got plenty of cash in the bank and you're comfortable saying, you know what, like we're not burning hard enough to where we need to worry about it. If you're in that stage,
or if you have a lot of AWS credits.
Yeah, exactly. If you got 100K of AWS credits in the bank, like find product market fit and wait for it to become a problem. And as long as your business isn't so fundamentally flawed in the mechanics that you can't in the future engineer your way out of it, that's fine. Like in my days of doing consulting, I would often tell people like, you don't need to worry about this yet. Like I'd have conversations with architects who are, oh, but this will cost so much, that'll cost so much. Guys, we're running like 3 services, and the throughput is low. You don't need to worry about it. It's fine.
Sure.
But for us, there are a couple of things that drove it. One is that we're a profitable business and we're essentially bootstrapped, right? And we'd like to just continue to remain profitable, or if we're going to operate at a loss due to investing in growth, when we decide to do that, we still want to have a comfortable cushion of cash. We still want to know that when we're adding customers, we're adding to the bottom line. We're not screwing up our gross margin, because that also makes us a much more attractive, if we ever wanted to be acquired, which, is not something really that's in the cards right now. Like we're comfortable running a profitable business and want to, but continue to do that for the foreseeable future. But if you ever did, well, people look at gross margin. That's one of the numbers to plug into your value of your company. So there are a lot of reasons to look at it. For us, in particular, it was, can we offer enterprise contracts at a discounted rate with certain parameters, certain limitations, given that we deeply understand company's usage pattern and you can put some limitations around that.
Got it.
And what limitations do we need to put around that? The other thing that it's letting us do as well is explore other verticals that we don't really service as much right now. We do a bit of, but isn't a core focus area, like infrastructure monitoring, where the usage patterns tend to be very different than in environmental IoT. Environmental IoT, for the most part, with some exceptions, is relatively low frequency of data, relatively low per device data demands of ingestion. Whereas infrastructure monitoring, they tend to blast you with a load of data. Like as a car is driving over a bridge or something, you're getting just blasted with all of this very high resolution data. So looking at those usage patterns and understanding our cost basis for different operations and mapping them to those verticals allows us to say, do we want to get into this? What would we need to change about our architecture, if anything, in order to service this at a gross margin that is similar to our current gross margin on most of our other verticals?
Yeah, that makes sense. So then can you share some details of like, how did you actually do this for your business? You mentioned you're multi-tenant and you can use AWS heavily. Those are really common things that other SaaS companies are kind of using. So maybe some details of, and feel free to share like any technology or tools you use as part of that as well.
Sure. Yeah. So for us, and I've done this actually for one or two other companies in my consulting days, but for us, this is actually probably one of the harder ones that I've had to work out, because we have all this data coming in, but we do have some shared resources. So when I took a step back and I said, okay, how can we do this? And step one was, let me just map out our architecture. And so I literally like mapped out in a Miro board with sticky notes, like here's our architecture, and here's this service, here's this component, here's this thing, and I did it in an event storming style. So I don't know if you're familiar. Yeah, okay. So you essentially lay down the domain events that are the business critical, business significant events that are happening in your system. So for us, it'd be something like a data source created or data source registered, acquisition triggered based on schedule, acquisition triggered based on device pushes data to us. All of these different things. You map out these events, and then you map out where in the architecture those events correspond to. And then you start to say, okay, which of these things drives cost, and what kind of costs are they related to? I could even, see if I have a safe to share copy that I could show you guys. But you do that and you create this really rich diagram and rich sort of thing that you can visually look at and say, when this thing happens, so when data is ingested, when an acquisition is triggered, then that causes, okay, well, there's some cost on our RabbitMQ, but is that significant? Maybe, maybe not. Oh, MongoDB, that's going to trigger that. And okay, when one of our data transformation processes runs, it's pulling data from MongoDB and it's pushing it to MongoDB, and it's also going to send an email over here, so that has SendGrid or SES costs. And so you get a really nice picture. And I'll just share a tiny, I guess I can't share it in the recording, but that's okay.
No, I just clicked on the multiple. Let's see. Try that now.
Let's see.
Lovely zoom setting. There we go.
All right, so I'll just share the portion of this that I think is okay.
Sure.
But basically what I did was I mapped everything out, and just scroll out a little bit. And I created this little map of like, here are all my costs.
Okay.
Storage costs, processing costs, data transfer costs, third-party services, and different variables that are impacting cost. And you can see I, just leaned heavily on the domain driven design and event storming stuff.
And at this layer, you're still focusing on like your application concepts, right? You're not really looking at AWS services or anything like that yet. You're still at that high level.
Exactly. And so you start to see, oh, these stars, what are these stars, that's interesting. Like, and we started to map things around like, which of these things are significant things that we might want to then monitor. So that's what those stars actually mean. So once we mapped everything out and we said, okay, these things are driving different costs, this drives a cost, this drives a cost, we looked for the common choke points in the architecture where it's sort of like, here's where we can monitor that. And that's when, that's where we drop into, I'll stop sharing now.
Sure.
Because I think that gives a taste
of
how we did it.
That was helpful.
And so you kind of map all of those costs out, and you can see in the diagram where I had a storage cost labeled Mongo and a storage and a processing cost and a this and a that. And so then the stars meant, okay, I actually need to go into the code and instrument that. So that's when we decided, okay, well, we need some sort of easy, quick data store to push things into, pull data out of. We actually just use New Relic for that. They've got a pretty generous free tier, and their custom events were pretty well suited to this. We don't use them for APM particularly, but for this use case, it just really is nice because you can go in there and it's sort of like, you can just play around with these time series queries, and they have an API that you can pull the data out of. So we got the data into New Relic, right? But that's not enough. That's just essentially our usage data. I had at that point usage data of things like, how frequently are data sources by customer, with the customer IDs, how frequently are those data sources being acquired? So like how frequently are we fetching data from them? How frequently are data sources that push data to us pushing data to us, and how big are the payloads? Then based on that, that as well as some other metrics, how frequently are we sending emails, things like that. By customer, we could then say, all right, let's join that with the AWS data from the cost and usage report.
Right.
And this was actually...
Ask a quick question before you move on to that. Roughly speaking, how long did it take you to do this kind of instrumentation? Is it fairly lightweight, sprinkling like some, some library calls here and there with your New Relic API keys, or did you have to write a lot of business heavy logic as well?
Because we went through the process of identifying those choke points, the places where we really should instrument. And it turned out that when we really sat down and analyzed it, there are some common points that are like the choke points where you can just, I can instrument it here and here, and that actually gives me an accurate picture of everything that's happening.
Okay.
There weren't too many places to instrument, probably 10-ish.
Okay.
Like there really weren't that many, right? It wasn't very hard. It took us maybe, I think I personally did it in maybe a day. It wasn't very long, right?
Okay. You were instrumenting things like the customer ID as well as like the choke point itself, so you could then slice that data, and that's why it kind of helps you do the multi-tenant side of things later on, right? Exactly.
And we would do things like I instrumented, and I had some instrumentation in there already just for other things, but so there were some interfaces and things that I could just in the code add to. So if you're already doing some instrumentation of your code, you'll probably know where you should slot things in. But you would add, customer information, and then as much information as you think you need, more the better, that you then would correlate. So things like, payload sizes, and for us, the number of days that a query spans, and the number of records that were returned from that query, and how often they're doing these queries. And so everything that you think could then correlate to an underlying infrastructure cost, whether that's a CPU spike, memory usage, storage costs like IOPS, anything that you even suspect could drive that, just throw it in there. And then you're going to want to do a deeper dive to analyze that.
Okay, and then you moved on to layering on the cost and usage report. So this is where you enabled the detailed AWS cost and usage reports. I'm assuming you did the one with the resource IDs. It's like the most complicated, the fat table.
Yeah, the biggest, whole shebang cost and usage report. And the first thing I did was I actually just got that hooked up to QuickSight. So I had it, the cost and usage report feeding into Athena and QuickSight. And I started to just try to dig into the data to understand like what's actually going on and where are my major costs. And actually, I had done that before I even did this cost attribution mapping. So I already had in my head a little bit around like, okay, these things cost a lot of money. So, I really need to make sure that when I'm doing this mapping of my architecture and when I'm doing the instrumentation, that I idiot check that against, where I know I'm spending money.
Sure. So then why not AWS Cost Explorer at that point?
It's not nearly granular enough. So like, I started there, but there are things that you need to drill down on and, slice and dice based on
like
that.
the usage
you just can't do it.
See the type of operation that was performed or things
exactly.
like that. Got it.
Because for example, a lot of our stuff, some of it's on containers in Fargate, but some of it's, a lot of it's EC2 instances and the burstable ones. And so you need to start really understanding, like when you're digging into this stuff, where are my costs coming from? And how do you get billed for the different Amazon or whatever your cloud provider is?
Yeah.
How do you get billed for those resources that you're using? In our case, the burstable instances in Amazon, they charge, you get a certain number of CPU credits, and then you use all of those and they replenish over time. But if you use more than you're allotted, then you get a surcharge for CPU credits, right? And that'll actually show up on your bill. You need to kind of understand that and know that and see that in Cost Explorer and or in the cost and usage report rather, and start to say like, oh, this one's fine. Like this service is very low CPU utilization. It never gets pegged on CPU credits. Okay, cool. This one, wow, I'm getting charged for a lot of CPU credits on this one. Oh, that's interesting. So that actually helps you understand in your architecture, like where you might also need to instrument things. So I think, in terms of an approach, looking at that usage data and getting pretty familiar with it before you even start mapping out your architecture and doing the domain event stuff, or at least concurrently with it, makes a lot of sense.
And then were you looking at, like, do you need the hourly granularity? So if you see a spike, then you can kind of correlate that spike to New Relic to see like, what was it? Okay.
Absolutely, 100% you do. Because at least for us, in our architecture and our customers' usage of our software, it's not constant. Like, we have some customers that pull out massive amounts of data every day to like, into other systems. And, it's a pretty flexible API and platform. So you get people just pulling out like gobs and gobs of data or publishing in bulk as well.
Okay.
So that means that our usage is very spiky at times. So, you might have sometimes, even if you're not auto scaling, your usage can still be spiky with those burstable CPU instances, right?
Okay. So then, so you've got now these two kind of rich data sources, and you can kind of correlate them. Then what?
Yeah, well, I mean, I think the first thing was in the cost and usage report in QuickSight, just really understanding like which costs I could ignore and which costs I could not. So, the eventual goal was build a spreadsheet or like a Python program or something where I could plug in a customer's usage based on like business relevant things. So like customer relevant things like how many fields are you sending me? How often are you sending them? And that kind of a thing. And then spit out a number. How much will this person cost me? And then be able to tweak certain numbers and say, if we limit you to this, we can charge you less. We can give you a discount, right? So in order to do that, you kind of need to know which are your biggest levers that are actually variable costs and which ones are fixed costs, or that you can pretend are fixed costs for now. So for us, we use RabbitMQ a lot internally. And we just have a big, beefy Amazon MQ managed RabbitMQ cluster. And it's kind of you can pretend it's a fixed cost because it actually is a stepwise function, but like it's, to hit that next step, you're going to have to add so much more that it's like, you know what, amortize that cost across all of your customers. It comes out to like a few cents per customer. Who gives a crap, right? Whereas, we use Mongo heavily for some of the data intensive operations. We use S3 heavily for, certain things where we're receiving files, and those costs are much more variable. And I could see that in the cost and usage report in QuickSight. I could see what kinds of operations were driving those costs. For Mongo, that got much more complicated. I kind of glossed over this, but I actually had to enable VPC flow logs and get that data as well into Athena, visualize it with QuickSight, and say, what things are sending data where? Because we're a data intensive application, right? If you had, just a little CRUD app that wasn't doing much data munging, probably wouldn't need that. But for us, data transfer costs were actually, they're a large portion of our bill. So I needed to understand and be able to attribute, just like I needed to be able to attribute a CPU spike. I need to attribute where is this data transfer coming from? Is it, from this ingestion box? Is it from our, processing servers? Is it from, where are they coming from? And also, how can I correlate that with, we use MongoDB Atlas, which is another hosted service, right? So how can I correlate which services are sending data to Atlas and different, Atlas boxes, and thus how can I apportion the Atlas spend to the different operations that my customers, at the end of the day, my customers are doing, right? So you need to kind of trace through the architecture and trace through, okay, if data transfer costs are a big portion of it, well, you got to know where those are coming from. So the way we did it, get everything into Athena. So get the VPC flow log data into Athena, get the custom usage report data into Athena, and then the New Relic stuff, we join that in memory in a Lambda function. So the way that we set it up is get all the data into Athena from AWS, so the flow logs and the custom usage report, have a Lambda that on a time interval joins that data up with the New Relic data, and then spits out a big CSV.
And that enables the kind of manual analysis to be done where you can actually plug in the customer numbers on the other side, or the hypothetical future customers or prospects. See what the unit economics kind of look like, I guess.
And so, like, the next step from getting that CSV, the CSV is basically your data joined up in a really nice way. But originally I went down kind of a red herring of a path, trying to use different forms of regression analysis to try to just say, can I just fit a curve to this? And like,
I see.
And that just didn't work. Like I tried all sorts of different, regression analyses and using, what was I using? Scikit-learn, and then I was like, maybe that's not good enough. And I was using these different, regression libraries, and it just didn't work. And when you thought it was working, it was because you were overfitting your data, right? So it's like,
that's interesting. Were you trying to see if there is like a common pattern where like it doesn't really matter what size of customer, like everyone's following the same kind of curve? Like, were you trying to simplify the problem essentially?
I was, but I had even broken it up. So I had basically said, what if I take the customer out of it for a second and I just look at a given hour, what's the utilization of the different resources, like CPU and a few different things. What's the kind of input the business relevant events. So like, acquiring data and, number of records that are being sent in and all that stuff. So, take the customer IDs out of the equation. Can I just fit a curve that's gonna,
Got it.
allow me to predict that? Because then if I can do that, then I get a nice simple equation that, hey, customer, you send me this many records, and then I can give you a cost for that, right? It just doesn't work. And the reason why it doesn't work, after taking a step back from going down that rabbit hole for a couple of days, was your costs aren't always these nice continuous things. And there's so much more richness that you need to apply to your model than can be done really in just these simple linear regressions. So I took a step back and I said, well, okay, let me actually just look at how my architecture is set up. For the things that are EC2 instances that we don't really auto scale up and down too much because we don't know when the burst deload is going to happen. We just know that it will happen at various times, and we need to handle it within our SLAs. So we can't really auto scale those up too much. We just need to be able to take the load. Let me look at the maximum load on those resources, because really what we're paying for there is the capacity.
I see.
We're not necessarily paying for the usage. So if I'm just looking at the customer's usage coming in, well, that doesn't really give me the full picture. And even when I was doing my clever machine learning BS, where I was trying to adjust for CPU normalized usage, it just didn't work. So instead, I looked at the max costs during times of max usage of a given resource, of a given thing. And then I said, okay, that's my capacity cost. But there is some fixed, some variable cost that's related to the actual amount of data customers are sending me. So let me model those two things discretely. So customer, if you want to send me 1 million records, there's some cost that I will charge you. If you want to send me 1 million records per second, well, now my capacity cost has to go up. Versus if you're sending me 1 million records an hour. Yeah. So you have those, two separate levers to play with that, in our case, I needed to model separately. So a lot of that kind of modeling, for example, has to happen in a spreadsheet, and you have to really think through, like, what's my architecture, what is my infrastructure, and how does that map to stepwise functions? How does that map to things that are where I have to just absorb it and I should model it as a capacity cost, like,
I see.
Versus something that's truly variable based on usage.
Okay, that makes a lot of sense.
Yeah.
And that is surprisingly complicated, right?
Oh man, it was very complicated, and the nice thing out of these models though is you're not trying to get perfect, but you are trying to get something that's close enough that it's very useful, and that's what is useful. Well, I mean, depends on your use case, but for us, I thought if I could get within 30% of predicting this, that's good enough. Wow. And okay, cool.
Very good.
Because man, otherwise it's like you go from having no idea what something's going to cost you. Like, are we going to completely lose our shirts on this contract to, okay, if it's 10% more, if it's 10% less, you kind of bake that in, and it's fine, right?
Yeah, we see that a lot, actually. It's our Infracost users tell us, like, I know you're not 100% accurate. Like, I don't want that, actually. I just want an idea of, like, is this going to, like, kill me? Or is this just going to, like,
totally.
Or is this actually something I should not spend any time on because it's insignificant and I should just keep going? Yeah,
that's exactly it. Because, like, you're not going to get it perfect with this stuff, because so much of it is just like, it's so variable, and it's just really hard because there's so many factors that can influence it.
Yeah, definitely. So then kind of stepping back, and if you were to like advise other companies who are kind of going through this or at the start of this journey where they're trying to look at the cost attribution and the cost numbers, what were some of the things you would advise them to do, or like, do you have any tips for them?
Yeah, so I think number one, ask yourself, do you actually need to do this? Or can you just look at what's going on in Cost Explorer or Cost and Usage Report and say, yeah, okay, good enough, like, fine. Or, you know, something like Infracost, if you're about to make a big architecture change, you know, like, is this gonna drastically change what I'm spending? Yeah, that's good enough. That's perfect. That's probably more than most companies or most developers would do, you know, without the finance team having to chase them down to do it. So you're probably in a good spot, especially if your application is not super resource intensive. But if you're doing things like, you know, building a data intensive application, or you know, doing stuff where you're just crunching loads of numbers, I mean, you'll probably know if you have one of those applications. I wouldn't do it too early, but if you're going to do it, I think, you know, mapping out the architecture using event storming and then trying to say which of these business significant events that are relevant to my customer can I find a common choke point in my event storming in my architecture where I can then measure those things and go in and surgically insert some measurement of those business relevant things and add all the data that you need. If you can do that and then find a way to join that with your actual cost data, and really think about what's your architecture, what are you being charged for? Are you being charged for capacity, variable usage, that kind of a thing? Then you're probably going to be in a good spot. And the other piece of advice I would give is it is going to be frustrating. It is going to be hard, and you're going to think, am I ever going to get to a reasonable model? Yep, you're going to have to take a step back a few times, reassess, analyze, you know, but that's okay. That's part of this. It's just hard stuff. It's a hard problem to solve.
So then this sounds like the kind of thing you might need to revisit every time you're about to make some major architectural change or add like a new component. Is that how you view it as well?
Yeah, I think so. Like, especially if you're looking at, you know, swapping out a major component of your architecture or moving, and you should know though as well, like based on doing that once, hey, if I change this thing, if I change my database, in my case, if I change which database we're using, well, okay, that's going to change how much data I'm probably transferring in and out, depending on whether it does back compression, you know, how chatty is it? If I split out databases per microservice, where previously maybe I had, you know, one microservice, now I've split them into two, like that might change things around. So you'll probably know by doing this once, you'll probably be 80 to 90% of the way there. Especially if you do, you know, what we did, which is for a lot of this stuff, try to push as much of it into code as you can. Like, you know, we have Lambda functions that are doing joining and spitting out a CSV in a well-known format. And that's like 90% of the effort, right? So I think you will have to revisit it, but hopefully it's easier the next time. And you'll also build the muscle. So part of this is if you haven't done it before, or even in my case, I've done a few of these before, but this, you know, doing it for Eagle was by far the most complicated one I've done. It takes a little while to get your brain thinking in that way and to know the ins and outs of the different AWS infrastructure costs and how they're charged. So it'll be easier over time, but you definitely should revisit it. You know, if you're looking at taking on a massively different use case with different usage patterns, or swapping out a major component of your architecture.
That is very cool. And then just one final question. How would you advise companies to like do this stuff if like one person like yourself, who's like really knows the architecture, like leads this, and then they kind of share the knowledge with the rest of the company, or like, or do you get like a little squad team, or how would you advise, like what kind of skills do you need to do this successfully?
So I think in terms of skills that you need a person or people who really know the architecture.
Got it.
And part of that one thing that can really help with that, if you're new to a company like I was, well, still am actually, getting like some distributed tracing going on if you have a microservices architecture, just so you can understand, like, wait a second, when this thing happens, 10 requests to that happen, or
Nice.
5 queries to the database happen. So like you can kind of idiot check your model as well to make sure that like reality reflects how you're modeling things. So that's a helpful shortcut to kind of cheat and give you some of that knowledge of the system. But definitely, I would say you need someone with knowledge of the system and also knowledge of the end users. So I was asking a lot of questions of our guy who leads up customer support and who's quite technical as well. But to understand, do customers ever do this? Do customers ever do that? Hey, I saw something in a trace over here. Like, is that normal? Like, I only saw one instance of it when I was querying for traces like that. But so having someone you can ask.
Yeah. Okay.
The other thing I would say is you need someone who either knows or wants to know way too much about AWS pricing and billing. And I built that up just by like diving in and doing it. I knew a bit about it, but it's definitely know a lot more now. But you kind of have to embrace it and really read through all this stuff. So you need someone who's going to be happy to do that. So if you have those two things, like the understanding of the actual user behavior to some extent, the understanding of the system, and understanding of the actual underlying dynamics of the different pricing models for whatever services you're using, AWS, Mongo, SendGrid, whoever, that's really helpful. And the one other thing I'll say that is useful is to have someone who has a bit of the business hat on. So in my case, I kind of put that hat on, right? But if you aren't really inclined to think of pricing models, and maybe that's not really your forte, depending on the company, maybe that's a product manager, maybe that's a salesperson, maybe that's the CEO, someone who is thinking about the actual pricing, user-facing implications, because you want to develop a model that's useful as well. So you need to kind of know what your end goals are, or what the possible pricing schemes are that you might be exploring, to then say, is the stuff that I'm producing in this model actually useful?
Totally makes sense. Those are this is, I think, part of the reason this kind of exercise is also very difficult to do, is because it doesn't require just one skill. It requires a variety of data sources and skills and kind of context from different parts of the business as well as the systems. All that makes it very complicated.
It definitely does.
Thank you very much for taking time to share that knowledge with the community. We're going to record this, put it on YouTube, and hopefully a lot more people will kind of learn. And we're definitely seeing a lot more companies look at this stuff, but the tools aren't there. The knowledge is just not there. So I think this was very helpful. Thank you.
No, thank you. That's fun to talk about this stuff. And 100% right. Like, I think the stuff that you guys are doing with Infracost is really exciting as well, because there just isn't enough awareness of this in the developer community, even on the business side. So, the more that we can do to educate people about thinking about costs, preferably earlier rather than later, the better. So, absolutely. And, shameless plug as well, if you're interested in environmental IoT, like, keeping the rivers flowing, making sure floods don't cause catastrophes or dams don't break, and, really having a great impact on the world, but also solving some really freaking cool engineering problems and product problems. We're going to be looking for quite a number of really smart, kind, empathetic, interested, curious engineers in the near to medium future. So get in touch. on Twitter. I'm sure that we'll have links to
Yeah,
everything.
we'll add links to your Twitter and add the links to your careers page as well, to the
awesome.
description, so people can reach out. I think it's very cool stuff you guys are working on, and it sounds like early in this space where like there's going to be a lot of stuff happening in that future.
It's very exciting.
Awesome. Thanks again, David. Cheers.
Thank you. See ya.